Okay, folks, let's take a look at question 4 on your pre-test. And you can extend these strategies to your pre-test on the other side of the page. So the first one tells us that we want to look at a sample of 3.7 grams of helium gas. And from that, we want to determine every piece of information that we can about the gas. We want to determine how many moles we have. We want to determine how many liters we have. We want to determine how many particles we have. So the first thing we have to realize is that helium gas is just a molecule. It's just He, and that the molar mass of helium, according to our periodic table or some other source, is 4.00 grams per mole. Based on that, we can start to do some conversions. We know that ultimately, we need to find the number of moles, we need to find the volume, and we need to find the number of particles. And we have to decide where we want to start. Well, as it turns out, the best place to start is with the number of moles. We can find the number of moles, if we're going to do this with the formula, by doing our mass over our molar mass. That is to say, we can do 3.7 grams divided by 4.00 grams per mole. And when we do that, what are we going to get? 0.93 moles. I hope my mental math is good there. I think it is. Once we have that, it's actually easy to find the other two things. For volume, at standard conditions, we know that we can do 22.4 liters per mole times the number of moles. So times 0.93. And if we work that one out, do 22.4 times 0.93, we get 20.8 liters. And actually, we have two figs here, so let's round that to 21 liters. To find our count of particles, we know that we have to do 6.02 times 10 to the 23 atoms per mole, multiplied by 0.93 moles again. And if we do that, if we do 6.02 times 10 to the 23rd, and we multiply that by 0.93, then we are going to get 5.59, or if we round up, 6.0 times 10 to the 23 atoms of helium. All right, so we had to make a number of calculations here, but they all just followed known formula, and it allowed us to find all the possible measurements we could want of this helium gas. We know its mass, we know how many moles there are, we know its volume, we know how many particles there are. And that's all I'm looking for these kinds of questions. Let's do the next one with conversion factors. This one tells us that we've got 50.0 liters of nitrogen gas. So that's 50.0 liters of N2 nitrogen gas. And if we look up the molar mass of N2, well, it's the combined mass of two nitrogen atoms, so it's 28 grams per mole. All right. We need to eventually find the number of moles. We need to eventually find the mass. We need to eventually find the number of particles. Let's start by going to the number of moles. So if I have 50.0 liters, I'll use a conversion factor to take me away from liters and to take me 2 moles. I'll take advantage of the fact that 1 mole, at standard conditions, has a volume of 22.4 liters, which gives me a calculation 50 times 1 divided by 22.4, which turns out to be 2.23 moles. Cool. All right, let's find the mass. If I have 2.23 moles, and I want to move away from moles and towards grams, I can take advantage of the fact that I know that there are 28 grams in a mole of nitrogen gas. So I can do 2.23 times 28, and I can get 62.4 grams. And then for my last one, the number of molecules, I can again start with 2.23 moles. I can multiply by a conversion factor that goes away from moles and goes to a number of molecules. And I know that 1 mole is 6.02 times 10 to the 23rd molecules. So if I multiply out, I get my final answer, 2.23 times 6.02 times 10 to the 23rd, which works out to be 1.34 times 10 to the 24th molecules. All right. So once again, I was able to start from one piece of information about the gas and find out everything else that I needed to know. I can do the same thing one last time for chlorine in the final question here. We'll try to be hyper efficient. So they tell me that I've got 0.89 moles of chlorine gas. 0.89 moles of chlorine gas. 0.89 moles of chlorine gas. I want to figure out, for each 1 mole, how many grams do I have? For each 1 mole, how many molecules do I have? For each 1 mole, how many liters do I have? Well, liters is easy. At standard conditions, I've got 22.4 liters. Molecules is a little tougher. I need to recognize that I have Cl2, and that the mass of Cl2 is going to be 70.1. Oh, sorry, I did that the wrong place. 70.1 grams per mole. As for a number of molecules, it is, as always, 6.02 times 10 to the 23rd molecule in each mole. So now I've got everything set up, and I see that there's some nice, convenient sort of symmetries here. I can do it all. I can do 0.89 multiplied first by 70.1. And if I do that out, I will get that the mass of my sample is 62 grams. Or I can multiply by my 6.02 times 10 to the 23. And if I do that out, I get that my number of particles is 5.4 times 10 to the 23 molecules. Or I can do it times 22.4 liters. And to wrap us off here, that gives me, well, 20 liters when I round up to 2 seconds. Okay, so now I've fully described this chlorine gas in terms of its mass, its number of molecules, and its number of liters. Based on the number of moles I started with, I'm happy, I'm good to go. Thanks for watching.